what are we going to build today? And as Jody already mentioned, it's this useless machine. As you can see, useless because the only interaction as a user that you have is literally flip that switch. And if you, once you flip the switch, the machine basically just turns itself back off. So that's why useless, and that's really all that it can do. So definitely an art piece and nothing that provides anything except for some enjoyment of seeing this thing struggle to kind of deal with your constant switch flipping. And kind of taking what I just mentioned before and applying it now is kind of like this list of requirements. So let's say you have this idea in your head, or you see this and you want to make your own version of it. Kind of what are the requirements for that? First of all, I guess you have to somehow detect, is the switch flipped? And if so, then I have to do something else. And if the switch is back in this position, basically keep the motor down there, something that handles the logic, which is going to be a little microcontroller. Already mentioned it a bunch of times, an Arduino in our case. And the other thing definitely is the switch. This thing here, clearly that's the one thing that we can interact with, and something that is actually moving this arm up and down. So some kind of an actuator. They're called actuators, basically anything that makes stuff move. So once you would go into and actually kind of do some research for all of these individual components that you need, these would, at least in my case, that's the list that I came up with. I'm using an Arduino, I guess a switch, and a servo motor. I'm going to go into all of these in just a bit, but that's kind of my ingredients list. Then we're going to test each individual component and wire it all up, do a bit of programming, and then kind of put it all together to make it do what we want to do. And yeah, I mean, so far I don't see any questions. Do feel free if anything pops up, but if not, then I'm just going to jump into the first step, which is going to be the Arduino itself. And I'm actually going to switch. Yeah, I'm going to switch to stop sharing, and there you go. Let's see. Oh, wrong camera. 1 second. That's the one. There you go. And that's what we're going to be looking at. So this is an Arduino. And as you can see, it really is a tiny, tiny thing. Like that's the palm of my hand. And that's going to take care of all the logic that has to be dealt with. What's really great about Arduinos is that they are really affordable. And with affordable, I mean, this thing costs between $5 or $6 per piece. So yeah, what's really amazing about that is it's just, even if you, let's say, you mess up and you fry one, it just doesn't matter that much because you didn't lose hundreds of dollars basically, but just $5 basically. And yeah, with that one, with the first look at that, let's start and write our very first program to make this do something that we want. Before we get into that, as you can see, this is just a normal USB connection. It's one of the older ones, but it's a regular USB cable that you can plug into that. So it's this. And I'm basically just going to do exactly that. As soon as I connect that, you can see some of the LEDs are starting to blink on that thing. I'm going to try to keep that in place somehow. There you go. Oops. So all that is currently lit up is this one LED here, which basically just tells us that it's powered on. And we do have this other LED down here, right next to it. And that's the one that I'm going to try to now make blink. It's basically a built-in LED, and we can just use that to do, yeah, the most simple of things. And let me, actually, I'm going to switch back to my camera for now and start sharing this. There you go. So this is, I should basically maybe jump into this first. So we looked at this, and that's going to be what we're going to be dealing with to make our things move and handle our logic. Now, time for this blink example. And I'm going to be writing that in the Arduino software. It's free to use, and you can just download it from Arduino themselves. And it works really well. Like, it's pretty nice to get into the whole thing and get started. So I'm not going to go into a lot of depth in terms of writing code. So I'm just going to write what we need, and I'm just going to explain kind of in broad terms what that does. It's not going to be a lot, but just so we don't spend too much time on kind of going through all of it. First of all, actually, I'm going to cut this out. These two very basic components are kind of the heart of it all in terms of the program. And the setup just takes care of initializing whatever you need to kind of do at the very beginning. So whenever you start up your Arduino, that's what it does. It runs through the setup, and it only does that once, literally at the very start. And then afterwards, it just goes into that loop function and runs this over and over and over again. And we're going to see how we can take advantage of that right now. So first off, I'm writing this line, which basically tells the Arduino that that built-in LED, basically the pin that is attached to internally, we want to use that as an output. So we want to actually have that emit light. We want to do kind of, yeah, do something, kind of get something out of it. On the opposite side, we could have this as an input. That would be for any type of sensor, let's say. That's when you want to have it as input. So LED is set up as something we want to have emit light, or basically emit any kind of current. And then we're going to set this LED to a state of high. Basically, it's going to be turned on at the very beginning of that loop. If we would leave it like this, we would basically just turn on the LED. But if we really want to make it blink, then I guess we have to wait, or basically, we're going to do this in between. I'm going to write those two lines first. This is going to turn on the LED, and this is going to turn it off. Problem right now would be that that happens basically instantly. This code, this loop function here, runs multiple thousands of times a second. And you can imagine that turning it on and off right away, it just basically won't do anything. It would probably just be halfway on and off. It would just be kind of dimmed. So what we really want to do is add a little bit of a delay. And I'm going to do that in this way. And what this does is just delay for 1,000 milliseconds. So, which is basically 1 second. So we're going to turn on the LED, wait for 1 second, turn it off, wait for 1 second, and that's where it's going to wrap around to the very beginning and start all over again. Now, I saw a little question, what language this is. It's actually very close to C++. Yeah, that's more or less what it is. As well, kind of the additional things that you can write for it, it's all C++ based. Don't quote me on that. Maybe you can write other languages too, but it's definitely going to work well with C++. All right. Now, with all of that set up, we can basically click the upload button, which sends it to the Arduino. And I'm going to already switch my camera back so you can actually see that. And as always, I chose the wrong one. There you go. And I'm going to kind of click the button and stop sharing so you can see this nice and full screen. And you'll see some LEDs flash. And that basically tells you that it's transferring some data back and forth. Right? We uploaded something new to the Arduino, and that's what this whole flashing was. And now you can see that this LED down here turns on and off once every second. Or I guess it turns on for a second and turns off for a second. There you go. That was the first little thing that we wrote for our Arduino. And I guess I'm going to do this. Cool. Then I'm going to jump back to, which one is it? This one. There you go. Next up, we need something that makes it easy for us to prototype. And it's maybe almost silly to talk about this, but I don't want to make, or basically I want to make sure that everybody knows what's happening. And earlier in the days, they would literally use a breadboard and hammer some nails in it and connect those nails with wires and lights and whatever they want to do. You can imagine that that is just not up to date anymore. We don't want to do that. And so we have this little piece, but it's still called a breadboard. That's kind of where the name came from. And it just allows us to quickly prototype because we can just stick little cables in it and wire things up very conveniently. And the way that this works is you have these two strips on either side, the plus and minus here, and those are basically just going to be connected. So whether you, or whenever you connect, whenever you stick something in, let's say here, and something else over here, it's as if you were touching those two wires together. So this is just internally connected together, same for the negative band here, and then same on this side. In the middle here, it's a little different. It just goes the other direction. So all of these pins are connected together, same for these. I only filled in these ones at the bottom here, but you can imagine that it's the same for the entire board. That's kind of the principle. So if I stop the sharing and do a little reveal, ta-da, there you go. This has already been here from the beginning. This is basically our little breadboard that we're going to work with. And I think, yeah, so before I go any further, what I'm going to do is basically just kind of plug that Arduino into the breadboard so we can use it afterwards. So I'm going to take that away so we actually see more. Going to disconnect it. I'm going to try to be diligent about that. It's always good to disconnect your electronics whenever you're changing things around. So I'll try to do that as much as I can. And I already kind of soldered in these little pins so that you can actually connect it in, which I'm going to do here. So it's just going to be that. There you go. Now it sits inside of the breadboard. And we get that nice and centered. And basically, this pin on the Arduino is now going to be connected to all of these. So whenever I stick something in here, it's as if I would have kind of directly soldered it to this pin of the Arduino. All right. That's kind of the very, very basics out of the way. So we can actually get going with, with a switch. Right? We took care of the kind of logic part of it. So we can already write a little piece of code that makes this Arduino do something. Now moving on to the switch. And switches come in all kinds of different shapes and sizes, as you can see here. But what we're going to use today is just a simple toggle switch, which is going to allow us to have that machine struggle eternally with us turning it on and off. And basically all that a switch does is just redirect current. So in this position, it's as if those 2 pins of those 3 down here would be connected together. And if you flip it over, it's as if those 2 would be connected together. So it just makes it easier than if you would have to kind of physically go in and start touching wires together, basically. You can just flip a switch. Now, the problem is, let me switch back to my camera for all of this. The problem is, how do you make the Arduino talk basically to that switch, right? Do you now have a switch? Fantastic, I guess I get the idea. And I have an Arduino and I can make that blink. All right, cool. But how do I now kind of merge these 2 things together? If you would just kind of connect one of these cables to the Arduino, it doesn't really know what to do with that. It's kind of looking at this input that, yeah, it's just a cable. Fine, okay. No idea what to do with that. So what we really have to do is kind of have some kind of a voltage on that that the Arduino can then detect. So that so basically one of these pins that we can use as an input and kind of sense whether something is happening, we can then look for, oh, is there a voltage or is there no voltage? So we need a voltage in the first place, right? So if we do that, we actually get a high reading on that digital pin. And by the way, like this 5 volts is one of the pins on the Arduino, just acts as a source of 5 volts, basically. But you can think of it as if you would have a battery. So you have a positive side on a battery. I think batteries are usually 9 volts. It's just a different voltage, basically, but it's the same principle. It's a source for electricity that you can then use in your circuits, just like this. And if you flip the switch to the other side, because this is no more connected, it basically then should go to low. So like this, it's kind of all connected together, and it will read as high. If you flip it the other side, it's reading low, and it should basically allow us to detect what that switch is doing. Well, not so fast, because if we would do that, then our Arduino would be very unhappy, because connecting this all together just like this is pretty much a short circuit, because there is no resistance in between that could kind of limit how much electricity can actually flow in that circuit. And I kind of have this little visual representation of what I mean with resistance and limiting currents. It's a little bit like a dam. So you can imagine you have all that water, all that energy at the top of the dam, and you want to make sure that that is kind of flowing controlled and not just all at once. So you want to have a little trickle of energy basically coming out at once. And if you wouldn't, if basically what's happening in a short circuit, it's all the water at once and disaster happens, right? You would fry your circuit basically. And well, we don't want to do that. Even though it's just $5 or $6, it's not nice. So, so that's kind of where this dam structure comes in. And in electronics, what that is a resistor. They're called resistors, and what they do is literally limit the current, the electrical current. And in those smaller circuits that you build for Arduinos, they basically always look like this. This is kind of like your go-to resistor. And they come with these little strips, and you can then kind of read off of that strips how much of a resistance that is. Right now, I'm not going to go into more detail of that. You basically just have to find the right resistor for your application, and you hook that up in between so that there is some kind of a resistance and you don't end up yeah, having a short circuit, for example. And with that, we can actually start, yeah, there we go. We can actually start building that up. So I'm going to go back to this camera. And now I got the right one. There you go. So what we want to do, we will have a switch, that kind of switch that we just saw. I'm sorry, I'm terrible with this mirrored view and all kinds of mirrored. But this is basically the switch that we want. I'm going to move that over a bit. So we're going to just connect that up somewhere over here. And for that, what I want is to connect one of those digital pins here to that switch. So I'm going to do this. Serve that. So it'll be done in just a second. There you go. Wonderful. So this is kind of the very first slide that we saw. This is now just connecting one of the connectors on the switch to the Arduino, right? It just goes all the way down here to one of the pins. Now we actually need the current. And for that, I am going to get that off the Arduino. And I don't know whether this is, it's probably not going to be readable, but let me tell you, this pin here is the 5-volt pin. And what I'm going to do first is just wire that over from this 5 volts to the positive side of this all. Bear with me. My breadboards are not as high quality as they could be. There you go. All right, got it. There. So I literally just connected this one to the positive side. Now, all of this is going to provide us 5 volts that we can work with. And I'm going to do the same. No, actually, I'm going to just keep going with what we have already. Where is my resistor? There it is. All I have to do now is introduce this little bad boy, which is our resistor, into the mix. So from these 5 volts here, I'm going to go all the way over there to the switch. And now we have basically what we saw on the slide before, which was we're going to go from 5 volts to this bridge, which just kind of redirects us over here, through the resistor to, oh, I'm an idiot, sorry. Of course, I already talked about that these things are connected along these lines, not sideways. All right, so 5 volts goes over here, goes through the resistor, goes through the switch. If it is turned on, it keeps going, and we'll be sensing that over on this side in that pin over there. I hope I wasn't in the way when I was showing that, but there you go. That should be the physical part. And now let's do the programming side of things. So I'm going to share my screen again. Arduino time. There you go. So we still have the code that we had before. Now it's just going to be a question of, well, when do we actually turn that LED on? And that should be when the switch is flipped, or in one of the positions, basically, when it's connected. So for that, we'll need a pin to be reading, the LED pin. I didn't mention it when I had the camera there, but I plugged it into pin 8. So that's going to go in here, and it will be an input. Now the Arduino knows, listen for that pin, because information is going to come in through that. And then down here, I'm just going to go and add a little if statement. I'm going to write it out. And I'll explain in just a second. Else, grab this line, and we don't need the delays anymore. All right, so I already mentioned this. This is just setting up our switch pin. And then from here, we're reading whether that switch is either turned on or off. If it is on, then we're doing this line. So we're turning the LED on. And otherwise, we're turning the LED off. That's basically what I did here. And again, it's one of the examples. Even Arduino itself has tons and tons of examples. Blink was what we did in the beginning, and then you have all kinds of examples, like the one that I'm just doing right now, that you can kind of reference from. But this should now allow us to actually toggle the LED through flipping that switch. So let's try. I'm gonna hook up the Arduino. That seems to be working fine. And right now you can still see that it's doing what we programmed before. It's still blinking. So I'm gonna go ahead and upload that new sketch. I'm gonna stop sharing so it's all full screen. And it instantly already started to be turned on because our switch is basically in the position that lets it be turned on. Now, if I turn it off, oddly enough, it's still kind of lighting up. You can see that it goes brighter when I turn it on, and then dimmer when I turn it off. But it's not really doing what we want. Why is that? And I kind of wanted to run into this problem intentionally so that I don't just tell you all the things and without really showing what happens if you do it wrong, but yeah, so that we can kind of explore together. So the problem that we had is that this switch is basically ends up providing a bit of an undefined state to the Arduino. What I mean with that is, if it's connected, it's definitely 5 volts, because it is connected to 5 volts and that's what it can sense. But if you turn it off, it's basically just in limbo state. It doesn't have a connection, yeah, but it doesn't really mean that it's on actually low. So what you really need to make this work and work reliably is to add a little connection to what's called ground. And again, with the kind of, so I'm going to turn on my camera so I can gesture a bit. Again, going with the analogy of a battery, you have the positive side and you have the negative side. What we did so far was kind of just pump out the positive side and not really deal with the negative side correctly. So you end up with this, and that should actually give it a reference point. So even if it's turned off, it kind of falls back onto that ground level. So when you flip the switch, it turns on, and when you turn it back off, it doesn't just kind of end up in that weird state, but it really goes back to 0. So let's do that. And I think, yeah, so I'm gonna again stop sharing. Sorry, it's a little bit of a back and forth, but I hope that it's looking all right for all of you. Cool. So I'm gonna unplug this, and we're gonna change things around just slightly. So we'll need ground. And ground, again, I don't think you can really see it, unfortunately, but ground is on this pin over here. And it's labeled, maybe I can just raise it up just for a second. Can you focus? No, you can't. All right, please trust me. This is the pin. So let's connect that. And I'm going to do the same. I'm just going to wire it into this entire side of for the negative. So this is going to be the ground. And in fact, I'm going to use these two long wires to make the ground accessible from all the sides. So from here and here will be ground, and this will be positive, and this will be positive. So I'm just going to quickly connect those before we keep going with anything else. So I'm going to connect this from here to there. Again, hopefully my breadboard allows me to. Seems to be the case. There you go. So now this is grounded, and it goes over here, and all of this is grounded. This is 5 volts, and all of this is 5 volts too. So we can put the switch back, and this time we will use, I think we'll use that one. Go from positive through the switch, and then from here, we will ground it so that it actually has that connection to the kind of reference frame, that it can go, if it's turned off and this is not connected, so it's as if this thing would be unplugged, the only thing that is happening is that it's grounded to 0. And once that switch is actually flipped to the position where it's all connected, then we get this nice current that we can detect by the Arduino. All right, this actually doesn't even need us to reprogram anything, because before it was just a hardware problem, basically. So we should be able to just connect this up again. And this time around, we should get the correct behavior. After that is done initializing and stopped blinking, we can now flip the switch. It's turning on, and there you go. Now it's turning off completely. And we can do that again and again and again, and it should work all the time. There we go. Cool, that takes care of the switch. Only one last component to go before we can actually assemble this, and I'm going to try to not dwell too much longer, because definitely, oops, going to run out of time otherwise. So, running out of time, check the switch. We're already good to go. We have what we need. Last piece of the puzzle, the servo motor. And this one is going to make our lives quite easy, because servo motors are basically a group of motors that have take a lot of the legwork away from us. Like, we don't have to work as hard because they come with a built-in controller. So instead of having a motor that kind of rotates continuously and you have to kind of stop it in the right moment to get the right kind of rotation, it already takes care of all that. All you need to do is tell it the angle that you want it to rotate to. So you just tell it, okay, I want you to rotate from here to, let's say, from 0 degrees to 90 degrees. And it just does it for you. That's the beauty of servo motors. This whole kind of built-in thing, you can see it a little bit in here. It's basically this gear system, and then the control circuit is somewhere down here. So makes our lives wonderfully easy. And all we have to worry about is basically positive, negative to provide it some power. And then the orange pin is going to be for the data, where we are going to tell it that's the degree that we want to rotate to. Actually, I'm going to connect that up first. Again, kind of go all in order. I'm going to stop sharing again, switch back to this, and let's add the servo to the mix. I'm going to disconnect this like the good citizen I am, and there you go. This is our little servo motor. Again, very, very tiny. Like, these things come in very, very small sizes. Doesn't have a lot of power, of course, but it's going to work fine for what we need. And as you can see, these are the wires that I was just talking about. So let's connect that to our system. Gonna put that somewhere on one of these free lines. Again, these are connected, so there's nothing going on here. I'm just gonna choose, actually, I already made one of these little wires to connect it all up. Just gonna choose, let's say this one. Let's have that dictate us where this servo should go. So here, I kind of made sure that I have an orange wire from the servo. I made an orange wire here, so we can line these up and connect it all up. There you go. So right now, all that we have for the servo is just the data. Again, of course, we need the ground connection and the plus 5-volt connection as well. And that's going to be that one. That takes care of ground. And this takes care of 5 volts. And that's actually it. That's all we have to do to make the servo do what we want. Let me kind of put that all a bit closer together. And I'm going to put this attachment onto it so we can actually see it better when it starts rotating. All right. That was the hardware part. As you can see, quickly reiterate, that's the connection to one of the pins where we can write the data, goes into the servo, and these ones I already mentioned plenty. And let me go back to sharing this little screen. There you go. Arduino time for, I think, the last time. Let's see. Now, instead of dealing with the LED, we actually want to do something else in here, right? We don't want to, we want to rotate the motor. And to kind of take advantage of what I said, that the Arduino takes away, like all that extra jazz of dealing with rotating and making sure that it's, let me switch to this camera, that it's at the right angle, we kind of have to use what is called a library. Again, you would find examples left and right for this on the internet, and you could just pretty much copy paste for your use case. So I'm going to basically use that library, and I can now use my servo. And I have to initialize that by saying that we attached that to, I think that was pin 4. Let me double check. Yep, and it literally says D4 on the Arduino. So that's how you know which pin that it is. So that's where the 4 comes from. That's where that 8 comes from for the switch. That's how you know. And then inside of the loop, it's actually really easy because we already have the if condition. So we already know how to distinguish between one state of the switch and the other. All we want to do is now switch this to my servo dot right. And let's say we're going to go to 30 degrees if the switch is in one position. And we're going to go to, let's say, 120 degrees when it's in the other position. Usually servo motors, or at least a lot of them, only have a limited range, 180 degrees and lower. So basically half a circle or less. And yeah, you basically would just find all of that on the data sheets of all of the servos that you can find. It basically says that. It just says that it has that in that range. And I just added a little delay that we don't kind of flood the servo with a ton of inputs all the time. It would just be a bit overwhelmed with that. So just to make sure, I'm just putting in a tiny delay. And that should be it. That should actually already kind of let us flip a switch and make the servo rotate. So I'm going to hit upload. And in fact, I'm going to, again, the wrong one. Every time. Come on. There you go. So I'm going to upload that turn off this sharing, and it's gonna fail because I guess it would be good if I actually connect the Arduino. So again, I'm hitting upload, and we're gonna see the LEDs flash a little bit. And there you go. Now it rotated into one position, and as I flip this switch, it rotates to the other position. And I switch it back and forth, and it does basically what we want it to do. And believe it or not, this is actually already all that we need to assemble this little machine. So let me switch back. Share screen. Because all that is now needs to happen is basically just the housing around it. So we have a switch that makes the servo motor rotate whenever it's in a certain position. Then the servo motor rotates, and basically that's all we need. I won't spend a lot of, or actually almost any time on the housing. I basically just put that together in 3D, and then 3D printed that to kind of make my life easier. So that went through and 3D printed that, and so it's assembly time, not this, assembly time. So I'm gonna go back to, yeah, camera is already there. Let's raise that a bit, give ourselves a bit more space, and here we go. So this is, these are all the pieces. I already kind of put these together. This is just a little flap. Oops, I can't see it. This is just a little flap that closes just by gravity. This is where the servo is going to go. This is a little arm that will push. And I basically just have another switch that has a bit of a longer cable attached to it, so we can wire it all up correctly. And yeah, let's do that. Let me check real quickly. Maybe it's helpful to have a bit more light. Let's see. All right. So I'm going to take this, and what we want in the end is kind of have that switch in here and wire the cables outside of the housing. So I can just wire that down a little bit, bending them. In the end, the switch is going to fit through like this from the top, like that. So I'm going to put that in here and then bend it over on the bottom here, like that. Literally just kind of wiring these outside of the housing. That should be taking care of the switch. All I need to do now is make sure that that switch stays where it's supposed to stay. And for that, I need a little something. Where that went. There. A little screw basically that goes at the top of this. So I can put this in here, put the screw on top, and screw that tight. Now that switch, even if I push on it, it's not going to fall out again. Cool. So we have this, and now I'm going to disconnect this circuit so we can actually mess around with everything. What I want to do here is somehow connect this arm to the servo. And I made my, made my life a little bit easier because there is this attachment for the servo. That's not easy to see. I don't know what's easier. I hope that works. It's unfortunate. I only had black filament for my 3D printer. But basically there is the opposite shape inside of this that I can just fit it in. So if I press that in, it now kind of is attached to this little arm that I 3D printed. And this attachment fits just like the one that I took off from the servo, fits really nicely onto this. And before I stick that on, I'm going to put the servo in its place. So it just has a little, it's very difficult to see. It's not helping. Sorry, combination of webcam and black filament is not great. So I'm going to put that in, and that's where it's going to live. I cut a little toothpick and made holes into my design so that I can fit this through so that it's held in place. From here, I'll take that arm and just attach that onto the servo. So now, whenever that servo rotates, it basically will rotate the arm. And hopefully now you can already see how it all will come together. Let's see, let's do this. I'm gonna grab the top piece, wire all of the cables out of that little opening there, and take that on. It's basically just a press fit for the whole thing. So now we have this little box ready to go. And now I would just have to take off my old switch and replace it with the switch inside of the house. Literally the same thing. Now it just happens to be that other switch. And as we connect this now, see how that works. There you go. Now, all kinds of things are not going right because the switch is basically hooked up backwards. So when it's like this, the arm comes out. And when it's like this, the arm goes in. The position isn't right. So now it would be all about fine-tuning this. However, without taking up overly much time, I might run over a tiny bit. I basically am going to pull a little bit of a cooking show thing here, where I'm just going to have an already made version of this. So we can skip that tedious part, where it's just going to be making sure that all the rotations are correct and all the other bits and pieces needed, so that I can actually show you that it really is the exact same thing as we just did. The circuit, hopefully you'd recognize it. It's basically that exact same thing. And the box absolutely is the same. And as soon as I hook that up, we should be ready to go. And this one actually has a couple more features. And that is that it has different animations in a way. I guess you can call it animation. Can I see a little bit better? So the second one, for example, becomes really annoyed and really wants that thing turned off. The third one is giving you a really sassy pullback. And the normal one where it just kind of goes up. And so on and so forth. So really, from here on, the sky is the limit. You can add basically different animations, whatever your heart desires. Now, before I wrap this all up, actually, almost going to be right on time. You might be sitting there and thinking, well, it is even called a useless machine, and it totally is. So what's the use? Why would you kind of tell us about this? Well, I think it's a really good example of something that you can apply in all kinds of different ways. Put this here and again try to get a little bit more in frame. So this one, just going to give you a bit of context before I use it. I had this idea for basically a clock that has like these flipping this display segment. And that's exactly what this is. So if you hit that switch, you can see that those flip to kind of a darker wooden side. And the way that they work is just with a little magnet inside of this. And if I flip this around, you might actually see something very familiar. There you go. It's a bunch of these servo motors. They're connected to an Arduino. And the thing in the middle, this time around, just happens to be a push switch, not a thing to like a flip switch. So as you can see, it's really just an example of many what you can do with a simple, even just that very simple combination of a button or a switch and a motor. And with that, I'm just going to go back here. Just going to mention really quickly that there are some really, really cool starter sets to get going with all of this. And Arduino themselves, they have one. And even if you go on Amazon and just look for Arduino kit or so, you find these, which are fantastic because they have all kinds of different lights and sensors and motors, and you can just even like sample projects and you can just explore and learn about the whole thing. And if you're interested in basically the code for my example and the 3D files to print your own little useless machine, I'm going to put them up soon. I just didn't get the chance to, but feel free to check back on my Instagram. I'm just going to send the link out as soon as I have it up. And yeah, now look at that, 1 minute over, but I'm still super happy to answer any questions. And yeah, I hope that you could follow along and had fun. There you go. And thank you so much for joining.
That was so great. I loved it. I love the useless machine. I loved how much character each version of it had.
Yes. It's really something you can just start to kind of, it's basically animation at that point.
Yeah.
It's
Oh,
really...
that was so wonderful. Thank you so much. I wonder, is there one question in the Q&A? Oh, just some. Oh, there is some questions.
Yes. You can use, I'm gonna run up for a second.
For anybody who can't see, the question is, what do you use instead of the breadboard in an actual system?
Yeah, so there's this thing called like breakout boards and such. Basically, it's just something along these lines. And I'm gonna get that in frame roughly. Okay, it's basically a bunch of holes, but it doesn't have some. It's not going to stick basically. Like you can connect wires to it, but you'll have to solder it up. So that's, for example, what I have in this little thing. Just going to switch one last time, I guess, to this. If I flip that over, you can see that this is not a normal breadboard, but it's actually one of those that I had to kind of solder the wires together. So that way it's a more permanent connection. You can even print your own circuit boards, but I guess that's a next level type of thing then.
So someone on Facebook was wondering, they said it was awesome, and then they were wondering what script language was it, by the way?
Oh, so yeah, it is basically C++. It's kind of Arduino's own language, but it's heavily, pretty much, yeah, based on C++. That's kind of what it is.
Perfect. I think that's all there. That was from Burnaby.
Thank you so much.
All right. Well, thank you so much for doing the demo. That was so cool. And thank you to everybody else for joining us. We have 3 more artist demos coming up this weekend as part of our virtual preview week. Tomorrow, Saturday, November 7th, Yes, there is a demo at 1 p.m. with Lori Goldberg about unexpected ways to upcycle your plastic bags. And at 3 p.m., there is a lino print demo with Kari Christensen. And then on Sunday, November 8th at 1 p.m., there is a encaustic painting with molten beeswax demo with Sherry Bartlett. So thank you, Mischa, again. And thank you, everybody, for joining us.
Super welcome. And I think just if you think that this was interesting and you know someone, I guess I'm going to have this presentation every Thursday, like the next 2 Thursdays. So feel free to join then.
And then people can also come visit you. They can make an appointment, right, to come to Octopus Studios and see you during the crawl weekends.
Exactly. Yeah. Just not on the Thursday because I have home
because you'll be here.
Exactly.
Awesome.
Friday, Saturday, Sunday, I will be there.
Great. All right. Thank you. Good night, everyone.
Good night.